Okay, we're going to start with a quick review over what you should already know about atomic structure. You do not need to draw this down because you should already have it. We're just going to do a quick review. Remember, our atom is made of 3 subatomic particles. We have our protons, which are positive, and our neutrons, which have no charge in our nucleus, which makes our nucleus together positive because of those protons. Out here in the electron cloud, we have our electrons, which are negative. Okay, so that makes the whole electron cloud negative. So we have a negative electron cloud and a positive nucleus. And we know that positives and negatives attract each other, so that's what holds our atom together. We also know that protons and neutrons are about the same mass. They're 1 AMU, or 1 atomic mass unit. They're so much bigger than our tiny, tiny, tiny electrons. Okay, so because they're so much bigger, most of the mass of an atom is found right here in our nucleus. Okay, all right, so let's go to what we are going to be talking about today, which is learning how to calculate atoms. Okay, on your periodic table, and I'm doing an example right here, but if you look at your periodic table that you've glued into your journal, okay, there's always going to be an example on every periodic table to remind you on how to read one. We're going to be using this in just a second, okay, but I did just draw an example right here to make it easier for us, okay. So our example here is sodium, okay. Our atomic number is at the top, and the atomic number of sodium is 11. The atomic number tells us several things, okay. The first thing it's going to tell us, okay, is the number of protons, okay. The next thing the atomic number tells us is who the element is. This is very important, okay, these two things, okay. This is why it's important. No other element besides sodium will ever have 11 protons, okay. So our protons are what helps us identify each atom of each element. So when we're looking at drawings of atoms, if it has 11 protons, it always and forever will be sodium. It cannot be any other element because our number of protons never changes. Okay, so the number of protons is the best way to identify our atoms. In a neutral atom, which means we have the same number of protons and electrons, if we have a neutral atom, then our electrons are also going to be the atomic number. Now, in chemistry and in real life, most of the atoms of elements are not neutral. Okay, they're ions, what we call ions, and we'll talk more about that later. So, for what we're doing right now, we're going to be drawing neutral atoms, but in a couple of days, you're going to look at ions. So, an atom that either has more protons than electrons, or an atom that either has more electrons than it's supposed to, or less electrons than it's supposed to, because we can lose or gain electrons, but this number, protons, will never change. Okay, Na is our chemical symbol for sodium. Here's our element name, and then down here we have 23, which is our atomic mass. Okay, our atomic mass is equal to the number of protons and the neutrons in an atom. So again, going back to our example that we drew a few days ago, most of the mass we find is in the atom. Now, on the real periodic table, you'll see a number that's not exactly rounded like this. It'll have a decimal at the end. And that decimal accounts for those tiny, tiny electrons that are they're just slightly bigger than 0. Okay, but for most purposes, we can round this number and just talk about our protons and our neutrons. Okay, so when we start drawing atoms, we have to calculate how many protons, electrons, and neutrons that they have. Okay, a great way to remember it is some acronyms here. We have APE-MAN. Okay, APE is the atomic number is equal to our protons and our electrons. Remember, only in a neutral atom, and we're only going to be dealing with neutral atoms today. Okay, Man stands for our mass. Our atomic mass is equal to our atomic number, which is also our protons, plus our neutron. This should say neutrons, not electrons. Okay, so a great acronym for you to memorize, 8-man, to help you calculate. Okay, again, very, very important. That's why it's written again. Most of the mass of an atom is in the nucleus. Okay, so what we're going to do now is we're going to practice these 3 examples. Okay, we're going to practice these 3 examples, finding their pin numbers and also drawing them. Okay, so I'll explain what this means here in just a second. Let's find our pin number. Our pin number is going to be our protons, our electrons, and our neutrons. Okay, so what we need to do is go to our periodic table and find lithium. So I'm going to flip mine around, and I'm going to find lithium. Okay, and you can see on your periodic table, lithium has an atomic number of 3, okay, and an atomic mass of about 6.941. So what we want to do is round that up, okay? So again, same rules in math apply. It's 6.9. So since it's 0.9, we're going to round up to 7. So our atomic number is 3, and our atomic mass is 7. Okay. So I'm going to write that right over here. Okay, so remember, like we just talked about, because our atomic number is always going to be the number of protons we have. So we're going to have 3 protons. Okay, we're only drawing a neutral atom right now, so our atomic number is also going to equal our electrons. Okay, and then in order to find our neutrons, we're going to have to do a little bit of math. What we're going to do is take that atomic mass and round it, which we already did. We rounded it to 7. And we're going to subtract our atomic number, which is 3. So that means we have 4 neutrons for lithium. Okay? So that's how we found our protons, electrons, and neutrons. Now we're going to draw a Bohr model. Okay? A Bohr model is not the model that we accept today. However, we still use it to help us draw the atoms because it's simpler. Okay? Remember, we use the modern day model, which says that our electrons are in this electron cloud, and they do have certain levels that they stay in, but they're not in nice, neat circles like we're about to draw. Okay? So, let's draw lithium. So remember, we're going to start with our nucleus first. Okay, so our nucleus has protons and neutrons in it. You should know that. So we're going to draw 3 protons, and I'm going to put 3 orange plus signs out here. Okay, and then our neutrons are 0 charge, so I'm going to draw 4 empty charges, or 4 empty circles to represent our neutrons. Okay, now here is where this magic number I was just talking about comes into play. Okay, you've seen models where we have rings or energy levels. Our energy levels can only hold so many electrons depending on which energy level they are. Okay, in the 8th grade we only go up to the 3rd energy level. So in our first energy level we can hold 2. Our second one we can have 8, and in our third we can have 18. Okay, now let's look. We only have 3 electrons here in lithium, so I'm going to draw my first energy level, and I'm going to put my electron out there. Okay, and I'm going to draw another electron. So there's my first energy level. It can only hold 2. So because I have 3, I'm going to have to draw another energy level. Okay, and I'm going to have to put my 3rd energy level out there. Now, this 2nd energy level can hold 8, but I don't have 8 left over. I only had 1 left over. Okay? This electron on the outermost shell has a special name, and that special name is called a valence electron. Okay? And those valence electrons help us figure out the chemical properties of this element. How does it react? Okay? It also helps us tell who it reacts with, and we'll talk more about that later when we get in specifically to the periodic table. Okay, for these next 2 examples, you need to try to pause the video and do them on your own, and then unpause the video to check your answers to make sure that you're doing this right. Okay, so let's go to nitrogen. Nitrogen on the periodic table is right here. Okay, our atomic number for nitrogen is 7, and our atomic mass is 14.007. So rounded, we're going to round that because it's 0.007. We're going to round that to 14. Okay, so since our atomic number for nitrogen is 7, that means our protons are 7. Okay, also again, remember we're only drawing neutral atoms right now, so that means our electrons are 7. In order to do our neutrons, remember we have to take the atomic mass, which we said we were rounding to 14, and subtract our atomic number, which is the same thing as our protons, and we should get 7. So this is why you have to understand how to find neutrons. Here in nitrogen, we got lucky and we have 777. But remember over here in lithium, our neutrons did not equal the same as our protons and electrons. So you have to make sure you know how to calculate them correctly. Okay, so since we already know our charges, I'm not going to draw them all. For our nucleus, we're going to put our protons, and I'm going to do 7p with the plus sign beside it. And that means we have 7 protons in our nucleus. And then I'm also going to do, for our neutrons, 7 neutrons with a 0 because they have no charge. I'm going to draw my first energy level. Okay. And I have 7 electrons to put out there. But remember, my magic number, I can only put 2 on the first one. So I'm just going to put 2 negative signs. Okay. Then that means I have 5 left over, and I can fit 8. So I should be able to fit 1, 2, 3, 4, 5 electrons there. I know it's kind of hard to see, but I'm running out of space here. Okay. So again, now my outermost shell is still not full because I can fit 8 and I only have 5. So that means that for nitrogen, I have 5 valence electrons. Okay, and again, that's going to be very important here in a couple of days. All right, let's try sodium. Okay. If we look at sodium, okay, sodium is the example that we used in our notes. Okay, remember you just drew sodium. Our atomic number is 11, and our atomic mass is 23 rounded. Okay, so that means our protons are 11 and our electrons are 11 because we're drawing neutral atoms. Our math, we're going to have to take our atomic mass rounded, which was 23, minus 11, which should be 12. Okay, so again, I'm going to have to draw real small here. We have 11 protons with a plus sign. Okay. And 12 neutrons with a 0 sign. To draw our first energy level, we have 12 electrons, so 2 can fit on the first energy level. That means I have 9 left. So 1, 2, 3, 4, 5, 6, 7, 8. I have 1 more left over, so I'm going to have to draw that third energy level and put my last electron out there. So again, the outermost energy shell is not full, so this guy is called my valence electron. So I only have 1 valence right here for sodium.